Still put sandbags in the back of our truck.
Well, you need to during the winter time.
Yeah.
Let's start here. We got monkeys. 16, x minus 3 equals 8. We're going to solve here. Okay? Can anybody explain what you want to do?
Put it in log.
I do not want to do either of those things. You could do a log technically. What I'm going to do is, can I get 16 and 8 to be the same base? What base can I be?
4.
8. I can't even be 8. Sorry, I was going to say not 8. 2. I can get them to be base 2. This isn't 16 2 to the 4th. What's 8? 2 to the 3rd, right? So I'm going to rewrite this and say, okay, this is 2 to the 4th, x minus 3 equals 2 to the 3rd. Does that make sense? Did I change the value of the expression? Did you plug those in already? Will you do that? One right there. Those green ones in. Okay, so now, what do we do on a power to a power? Multiply. So now I'm at 2 to the 4x minus 12 equals 2 to the 3rd. Hello? Welcome. So now, because they're like bases, what can I do? Just solve, straight up solve. 4x minus 12 equals 3. 4x equals 15. X equals 15 fourths. Is there another way to do this? Steven, what did you say again, bro?
Put it in log form.
Put it in log. Let's go to log. So how would I write this as a log? You got it. 16 base. So log base 16 of 8. Of 8. Okay. Everybody see that? To the machine! To the machine! See, I can go to the machine. Just like you can now. So, then I'm going to go. Log, so that was log base 16 of 8. So I could do this, my alpha F2, right? Go to 5. And go, okay, I'm going to put 16 in that sucker. Come on, Jose. Over. Put a little 8 in there and say, what is that answer? 0.75. Which is 3/4, right? And then I go back over here. So that's 3/4 equals x minus 3. Then I add 3 over, so x equals 3 and 3/4, which is 15 fourths. That makes sense? I would prefer it in a fraction, yes. Especially when you could get them to the same base, I want them as a fraction. How could you do that? Okay, so what did I have to do there? Add 3, right? Okay, so I'm going to go watch. Plus 3. 3.75. And then I go math, fraction. But I want you guys to think. There's going to be parts of your test that's non-calculator. That might be non-calculator. So that's why I showed you both ways.
Where's the fraction?
Hit math. Frac.
Okay.
If you ever want to know what I did, that's what this is. With me? Is that hard? We could do that, right? But what if, let's make it a little harder now. What if, okay, they aren't going to be the same base? So I'm going to find one because those are all the same. You guys want me to do another common base again? Or?
Yeah, let's do that. Why not?
All right, you scallywags. You scallywags. I love you all, but you're all, no, you're not. I forgot I gave you the definition of scallywag earlier. No? Okay, we're going to leave it as that then. The third one down. The pirate prostitute. So, I don't want y'all to be scallywags. Austin, you're too pretty to be a scallywag. Okay. That was recorded, by the way. What did Ron say? Okay, here we go. So, can I get 81 and 3 to be the same base? What base? 3, right? If you know your powers, it makes things a whole lot easier. To be honest, how many of you guys know all your squares up to 20? All your perfect squares. Ready? 1 squared. 1. 2. 4. 3. 9. 4. 16, 5. 25. 6. 36. 49. 64. 81. This is getting a little slower. 100. 121. 144. 169. 196. 225, 256, 289, 324, 381, 400. Okay? So, I would suggest you know those up to your squareds, up to 20s. Hopefully you know your cubes up to your 6s. 1 cubed. 2 cubed. 3 cubed. 27. 4 cubed. 64. 5 cubed. 220. It's 125. I decided. Okay, that's 5 cubed. What's 6 cubed? 216, I want to say. 216. Okay. How about your fourths? I know up to my 5 to the 4th.
I know what 3 to the 4th is.
1 to the 4th. 1, 2 to the 4th. 16. 3 to the 4th. 81. 4 to the 4th. 256. 5 to the 4th. 645. Huh? Oh, no, 6.
What's 6 to the 4th?
I don't know where I got that monkey. Actually, somebody gave it to me as the one day. They're like, here, Mr. Robertson, they gave me cookies. It was for Christmas, and I just kept it. And then somebody gave me the little monkeys on top, too. The blue and the... I don't know why they give me monkeys. I really don't like monkeys. That's the worst part of the zoo is the monkeys. My wife's like, let's go see the monkeys.
That's why you like Pokemon.
Instead of what's her bucket?
Jane.
No.
Jasmine?
Huh?
Jasmine?
Jasmine.
Oh.
Because she's got monkeys around her.
How do you Jasmine have to do with monkeys?
Abu.
Abu?
Abu. She has a tiger.
But Jane is with Tarzan.
I actually like gorillas. Nice. Seriously. Thank you.
They're in the same.
Like bases, what do we do?
Just do the top.
Steady.
So we set them 2x plus 2 equals 4. So we subtract 2, negative 2x equals 2, x equals negative 1. Can we check it if we wanted to?
Yep.
Sure. Negative 2 times negative 1, 2 plus 2 is 4, 3 to the 4th is 3 to the 4th. So that's why I wanted to stop all that. Awesome sauce. Next page. There we go. 15 raised to the 3x equals 285. Notice, guys, I didn't ask you if you know your 15s. Unless it's squared. What's 15 squared? 225. That ain't 285, is it? Here we go, ladies and gentlemen. Ready to do this one? What are we going to do?
Logarithm.
Put it in a log. Go. Put it in a log. What's up, Chuck?
Log.
How are you, buddy?
Oh,
Coming today. All right.
Yeah, I won't miss any more classes till now.
Isn't the Elcon already done?
No, I have like that.
Oh. Awesome.
Log
Okay. So how are we going to write this as a log? Log base of equals. Plug that in your machine, people. Let's go to the machine. So this is how I had to do it, by the way. What I had to do back in my day, because we didn't have that button, like I said, so I had to do change of base. So I had to do ln of, what was it again? 15. No, it was ln of 285, wasn't it? We have to do the 285 first. Divided by ln of 15. No, yeah. Did everybody get 2.08? Same idea, right? Okay, now 2.08, so that answer, I'm going to keep it on my calculator, equals 3x. So now what do we do? So we come back here and we divide it by 3. 0.6957. Make sense? You're going to have decimals as part of your answer today.
So you can't do that kind of way.
Yeah. You would have raised.
Huh?
They could.
Let's see if it has it in my instructions here. It doesn't say, but it'll probably tell you. Could probably be 100. This one's in the book here. I just have the book basically. It's rounding to the 1,000. Okay. All right, you guys ready for another one? So now I'd like you to try it on your own. 5 raised to the 2x equals $1.30. Okay. Log base 5 of 130 equals 2x. Okay. So I can come to the calculator, and I'm going to hit this time. Suck. That's why I don't like you anymore. Nice. It's a little bit slower.
Math, alpha math.
Oh, is that what it is?
It's a shortcut.
What is it? Math?
Math, alpha math.
Oh, now I'm a base of the base. Whoa.
The base of the model.
Math, alpha, math. All right, so what was it? 5 of 130?
I don't think it sounds like a shortcut.
I don't have to move my finger. Okay. So it's 3.02 divided by 2. 1.51. Now, how am I going to ask you guys to do this on your homework? Or not your homework, but on your test. You guys know I like work, right? So what do I expect you to do? This is what I expect you to do. Okay? So on your test, you're going to say, okay, what was this equivalent to again? Equals 2x, and then just, you get what I'm saying, just divide it up for me. But make sure you're, once again, when do we round? Even though you're doing this, I'm not rounding until technically when? The very last step. Does that make sense to everybody? We okay with that? Okay. X equals blah, whatever. What was it? X equals what?
1.512.
Okay. Awesome. Were y'all doing okay? Was that hard? All right. So that's pretty simple, really, right? Pretty simple. Oh, okay, okay. I like this one. We'll do this one. Ooh, that's a little bit tricky to get here.
That's what is
That's 7 minus 2e raised to the x over 2 equals 1. This one's a little bit trickier. Aloha, I'm out there. They're going to Hawaii, so that's why I said aloha. Okay, what do you guys think I gotta do? Can I put it into a log yet? So I gotta get this guy by himself. Okay? So I'm gonna subtract the 7. Negative 2 equals, oh, not equals, e x over 2 equals negative 6. E to the x over 2 equals 3. Now, ladies and gentlemen, nope, because it's 1 minus 7. Okay, ladies and gentlemen, I'm going to show you my work right here, right now. Okay? Whenever I have an E or a 10 as my base, guess what I do? I just go, ln. Why do I do that? Because remember, what did I tell you if I put, now if I did L on the one side, I got to do it to the other, right? That makes sense. Is everybody good there? Now notice, what does this E and this E do? They're gone, so this is just x over 2 equals ln of 3. Now, the other thing that you want to be careful with, I'm going to come back to these questions a little bit because I don't know how it might ask you on your homework. So, sometimes, what if I want the real answer? Do I want to plug this in my calculator? No, I want to leave it like this, so then I do this, x equals 2 ln of 3. That would be my real answer, wouldn't it? Does that make sense what I'm saying? Yes, no?
Yeah.
This is real. It's not an estimate. Because as soon as I put ln of 3, that's technically an estimate, right? Because it's a decimal that goes on forever. It's an estimate. True or false?
True.
No. Okay, so this is technically the real answer. This is real. That's not a decimal, correct? So, now if I wanted you guys to, we could all change this into a decimal. That's not hard. Let's go back to this question really quick. How would I give this as a real answer? Well, this is something I just thought about, and I'm thinking about it, just because how we had to solve it back in the day was change a base. You guys don't have to do that. And so I'm curious if the computer or the machine or the homework is going to be allowing us to do decimals or they want real answers. Because the way you guys have been doing it is just plugging this in your calculator and then dividing it by 2, right? That's not the real answer though. Okay? You couldn't even say, oh, this divided by 2 is the real answer. They wouldn't even accept that, I don't think, as the real answer. Does that make sense what I'm trying to say? How would I write this as the real answer then? Well, tell me what log of 5 of 130 is again. It is log of 130 over log of 5 equals 2x, right? So now I just cut it in half, correct? So now it's x equals log of 130 over 2 log of 5. I'm wondering if they want it in real answer. I'll have to check that. But if they do, that's the real answer. You get what I'm saying? I'm kind of glad I thought about that. It doesn't change it. Like, even if I put this in my answer, I'm still going to get the 1.512. It's just writing it so that we're not using decimals. Decimals are not real. In any mathematical form, you never have, like, they'll never put them in decimals. That's exact, real, exact, yes. Okay, so let me show you. I'm going to do this problem again because it's different. I didn't solve it the way I used to solve it back in the day because Miss Spangler said something. I'm like, I never ever thought about that. This is how I was taught. Okay, how do we get stuff out of the exponent? We need a logarithm, don't we? So what I do is, once again, I write ln's. Why do I write ln's? Less letters. Okay. I just did the ln. Now what does that, when I have a log and an exponent, what does that allow me to do?
With the exponent over.
I can bring it out front. Oh, sorry, thank you. I was like, that's a little weird. As long as I do it to both sides. It's like taking a square root of both sides. It's an operation. When I multiply something to both sides, it's the same thing. You guys gotta understand it's like an operation. It's like a square root. I can square root whenever I want, right? As long as I do it to both sides. Okay, so this is 2x. I apologize. ln of 5 equals ln of 130. Now what's the thing that's not x? The 2, the ln of 5. Right? So x equals ln of 130 over 2 ln of. Make sense? Yes, no? How is that the same as the last answer? Oh, was it x divided by 2 originally? You guys see what I'm saying by that? Yep. We're okay by that? So now using, on this problem, the same way, I'm going to do the problem all over again. And I'm going to show you, what was it again? It was 7 minus 2 e to the x over 2 equals 1. And we all understood that you got down to e to the x over 2 equals 6, right? No, 3 it was, wasn't it? Well, just like after we did all of that.
Yeah, that's right.
Okay? And then once again, if I take the ln of both sides, even if I treated this like e, right? Okay, I would have x over 2 ln of e equals ln of 3. Okay, then notice ln of e, this is just 1. So that's why I'm at x over 2 equals ln of 3. X equals 2 ln of 3. Okay, it's actually pretty simple, right? Okay, so now, I think we're getting close to being, oh, we still got a lot of time. Awesome, okay, here we go. Awesome. Okay, so I like to talk about money, right? How many of you guys have taken financial lit already? Financial lit. You've heard of the rule of 72, right? I don't know what the hell the rule of 72 is. I know it's used. Is it really? You do 72 divided by your rate, isn't it? And that tells you how long it takes to double. Okay, so, but mathematically, let's do something, okay? Have you guys ever, I showed you the PERT equation when we're compounding continuously, correct? Okay, so like for example, I have my $1,000, okay? That's what we're going to plug in, right? It's compounding continuously at a rate of 4%, let's say. I want to know how many years will it take to double. Okay? Does that make sense? Yes, no? You guys ready? Okay, here we go. So because it's compounding continuously, we have the equation PERT. A equals PE to the RT. Right? So how much is my principal? 1,000, right? E, what's our rate? 0.04 T, correct? What's the amount? Because we want to know how long it doubles. So I'm going to tell you though, sometimes in the problems they won't even give you an amount to put in there. Why? It's the same amount of time to double a penny to 2 penny and everything. Because notice, if I put a penny here, what's on this side? 2 pennies. So you can plug any amount you want in because it's the same amount of time to double. Does that make sense what I'm trying to say by that? So we get to this step. Okay, here we go. So we take 2,000, we divide it by 1,000, we get 2 equals e to the 0.04 t. Is everybody there with me? Now how do we solve for t? I'm going to take the ln. Why would I take the ln instead of a log? Ln gets rid of an e. A log does not get rid of an e, does it? So that's why I'm going to do it. ln. But I'm always going to take an ln because it's log. Unless it's base 10, then I'm going to take a log. Make sense? ln base 4 would never happen. What's ln base? So you can't have another base besides 4. I mean besides e, right? Does that make sense? I think you're still getting messed up on that. That's alright. Are you okay with it though? Yeah. Okay, so this is ln of 2, but ln and e get rid of each other, don't they? So 0.04 t. And then what? Divide it, so t equals ln of 2 over 0.04. Now we actually want to find how many years, so we're going to go to the machine here. ln of 2 divided by 0.04. 17 years to double your money. If you're compounding continuously,
Then that little 42 doesn't even work. So that's 18.
it's a close thing. 18, 17.3 years.
What's
It's the estimate. It's not a real legit thing, but it's close. You see what I'm saying? Sure.
just for a side note, how do you take into account inflation?
You can.
I was just wondering.
It's still, your money still doubles,
Yeah.
but inflation, really, you gotta think about it on average is 8% every year. That's what they really think about. So if you're not making 8%, really, you're not doing anything with your money. So if I had an account of 4%, just go spend that money anyway. Not really, but you get what I'm saying.
Yeah.
It's not gonna be the same amount, supposedly. Exactly. But you just gotta understand that money's not gonna be the same amount. Okay? You still have $2,000, but that $2,000 might not buy the same amount as it did when you put it. Make sense so far? You guys wanna try another one? I wanna see, I wonder if we have some Newton law cooling in this. Oh, now we gotta do these laws. Okay. This is a big lesson. Alright, let's try to do this. This one's really simple. These ones are a lot easier. This one's simple. Now we just solved exponentials. Now we're solving logs, right? Anybody want to tell me what you're going to do? Instead of going from an exponential to a log, we're already in a log, so let's go to, that's really a general rule. If you're in logs, go to exponentials. If you're in exponentials, go to logs. Really, that's what it is. Okay, so what's our base? What's our power? -1, right? Equals? So this is 1/10. You could multiply everything by what, so you don't have to play the fraction. So that'd be 1 equals 30 minus 20x. It's a lot easier than playing with the fractions, right? Minus the 30. So -29 equals -20x. Now, we have to be careful here on this one though. Just like remember last test how we had to check our solutions. With exponentials to logs, usually we don't have to check our solutions. But when we're going to logs to exponentials, we start making math work. So I have to plug this back in. What's 3 minus 29/20ths, or 2 times that? So notice now that's log of 3 minus 58/20ths. Whoa, what the heck? You guys are doing decimals? Come on now, people. So this is 3 minus, this is the same thing as 60/30ths, or 20ths, right? So isn't that log of a tenth equals -1? Does that check? Yeah. It does. Now, if this ever comes in, what number can that never be? It'd be 0. It'd be 1, couldn't it? Because 10 to the, what power gives you 1? 0. Could it be a decimal? Yes. Can it be negative? 10 what to raise to what power could ever be negative? So when you plug it back in, even though your math might work down here, when you plug it back in, it better be positive. This part right here. Does that make sense? Mm-hmm. So let me see if I can find. Yep, like this. Something like this. So this is also why we taught you condensing, expanding beforehand, right? Because now what am I going to do probably? Condense, correct? Can somebody tell me what this would be as a condensed problem? You got to distribute them both. Because this is technically x minus 3, right? Now what? This is in parentheses still, sorry. Woo! Hold on. Oh, I got a meeting in just a minute. Hello. Hello? I will be, but just give me a second. I'll be down in a while. Bye. All right, so what's the base? 10. What's your power? So it's 10 equals x squared minus 3x, right? You see that? Then what are we going to do? Minus the 10, and we're going to factor or quadratic that sucker, right?
Wait, did you just, what happens to 1?
1, because this is 10 raised to the first power, which is 10. This is technically 10 to the first, right? So if that was equal to 2, what would you do? It'd be 100. Is everybody there with me? Okay. And then we factor. Can everybody see the factors of that? X plus 2, x minus 5 equals 0. So what's x? 5. Okay, so let's go check our answers. Okay, let's go check. Here we go. Go back up to the original. Plug in 5. 5 minus 3. 2. That would be a 5. 2 times 5 is 10, and log of 10 of 10 is 1, isn't it? Plug in 2. What's 2 minus 3? Boom. Negative 2 is no longer a solution. A negative 2 wouldn't be a solution. Okay, because it would be log of negative 5. Does that make sense? And that's not possible. Yes, no?
So both, like one solution is negative and.
Doesn't matter if it's negative or positive. Go check them.
Right, but what I'm saying, one, if one of the solutions is negative and this up here is negative, you automatically take that, right?
Well, even if that was a 7, right? And you went 7 minus 10.
Yeah. Like,
Just when you plug it back in, the part that you plug it back into, so up here, I know, I see what you're asking, but just plug it in. It doesn't matter the number, because if this was negative 2 plus 3, it would work, right?
right, but if that was also.
If this one worked and this one didn't work, then it's no solution either. Just this part cannot be what? That's the key.
So
after you plug it in.
plug in the negative minus 3, it automatically takes it off.
Yeah, exactly.
That's what I'm
We good there? Okay, I'm just thinking here. Obviously, you might have some ln's and e's. Okay, what would you do? I'm just making one up here, guys, so just bear with me. What'd you do there? Do the same thing, right? So that would be ln of
X squared
minus x minus 2 equals 1. Then go x squared minus x minus 2 equals what? E. Now he ain't pretty, is he? No. No, then you're just back to here. So what you'd technically do is you'd subtract this over, and then I'm not going to make you do this. That's one number. That's your C value in quadratic formula. Sometimes you actually have to do that later in mathematics, get some nasty stuff, right? But I'm not going to be so mean right now. When I was making this assignment, I got my inner nerd going on. I was so excited because this is the stuff that made me like this. And Mrs. Spingler's like, that one's a little tough. And I'm like, oh. She kind of held me back a little bit. So you're grateful she was around. How would you do this one, guys? Like, for example, really quick. If I had e to the x plus e to the negative x equals 2. This one's one of my ones that I was going to put on there, but she wouldn't let me. I was so excited. This is e to the x plus 1 over e to the x equals 2. And then, I don't like fractions, so what am I going to multiply everything by? So that's e to the 2x plus 1 equals 2e to the x. Then what do you guys think? Subtract them over. E to the 2x minus 2e to the x plus 1 equals 0. And then you guys remember good old u substitution? U equals e to the x. So this would be 2u, or u squared, minus 2u plus 1 equals 0. I'm having fun here, but you guys probably didn't like this. That's why she told me no. But, and then you factor this is just u minus 1 squared. Right? But what's u? E to the x minus 1 squared equals 0. I'm almost there. E to the x equals 1. What's your answer? Because I took a square root of 0.
That's all you do.
That's all you do. Pretty fun. That's it, guys.